Hello and welcome to Verx Gaming. My name is Professor Robert, and today I'm going to teach you all how to do binary. So binary is actually pretty simple. It's a very simple concept. So to start, let me just write some binary numbers. So right here, now you probably think that this is 11, but in binary this is not 11. I'm going to use the congruent symbol. I don't know if that's correct, but I'm not going to write equals because that'll probably throw people off. So I'm just going to use the congruent for now, just because that's nice. So this conjoining symbols in binary is 3. So that's congruent to 3 in base 10. So we use the base 10 system, and I'll explain what that means, and then you'll understand what binary means after that. So let's write out the number 110. So we have 3 places. We have our ones place. So we're going to write that as 10 to the 0. Because 10 to the 0's power is 1. Then we're going to have our tens place. 10 to the first power. Now that's 10 to the first power is 10. And now the 100ths place, which is 10 squared. Whoop. So now you know that we can separate all these up. So what we could write this as is 100 plus 10 plus 0. So that's taking each number and putting the respective amount of zeros behind it. And that's why base 10 is nice and simple, because each number gets a 0 behind it because we're using base 10. Whereas binary, now this is what makes binary different. I just realized I'm sitting here pointing around with my finger as if I'm sitting in front of a class here. What makes binary different, so we're going to write the same number. Well, not the same number, we're going to write the same symbols. So let's do our 3 places again. Now, this is what we use, and it's base 10. I don't know if there's a fancy name for it, but we're just going to call it base 10. And binary is base 2. Finish this. Base 2 and then base 10. So base 10, we have 10s down here. Base 2, we're going to have 2s down here. So here's our ones place, which we're going to write as 2 to the 0th. 2 to the 0th power is 1. Here's our 2s place. 2 to the first power. And now our 4th place, 2 squared. Now the reason it's called base 2 and the reason we have 2's at the bottom here is because binary you only use 2 symbols. All what we have in binary is 0 and 1. So you have to make every single number possible, every single number combination possible out of these 2 right here, 0 and 1. Which is why if you add this all up, so we have 1, 4, that's 2 squared is 4. We have 1, 2. And we have 0, 1s. So this number right here, what we've written is 6 in base 2. If I wanted to write 6 in base 10, I would just write my 6. So these group of symbols right here, they look the same, but because we're in different base systems, it's not the same. It's kind of like if you drew 2 triangles. So if I have a triangle like this, and I have a triangle that is exactly the same, so you know what, I'm just gonna use my wizard skills and make a triangle that is exactly the same. So now they look exactly the same, but now if all of a sudden we throw an XY plane in here, so this is just a group of functions on our XY plane. Whoop. And now all of a sudden we figure out, even though it looks the same, this one has a bottom length of 5, and this one has a bottom length of 1,000. So even though they look the same, they are different because of the scales. So that's what you need to realize about these 2. Even though they look exactly the same, these are not congruent. Let's just scribble that out. This number is 6. This number is 110. So you got to remember that. And another thing, as I said, we have 2 symbols over here because it's base 2. Let me clear my board here. Full speed. There we go. Oh, whoops. Alright, so for base 2, we have our 1 and our 0. Let's write that nicer. 0 and 1. For base 10, I'm sure you guys all can do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We only have 10 symbols, which gets up to the number 9. You'll always notice, no matter what the base is, except base 1, if you want to think of base 1's kind of like tally marks, just without the cross slash, I guess you could call something else. But if you didn't cross slash and this is all you did to count, that would be base 1. There's one symbol, and you just count that many times. But any other base, you just take the base number. So base 2, you subtract 1, and now you have the final symbol. You only have symbols going up to 1. You take 10, you only have symbols going up to 9, and that is because there needs to be a 0. So that's the basics of binary. Next video, I will do some number conversions just to help you guys practice this stuff. Alright, thank you so much for watching. I'll see you in the next one. Goodbye.